Hello everyone, this is Samirian, and in this video I'm actually going to take a step back and we're going to take a look at one of my favorite creativity toys that there is, and that is of course the logic gate. And we're actually going to go through all the properties and the inputs and outputs of the logic gate and try to explain why it's just about the most powerful creativity toy out there and some of the uses for it. So, as you can see here, I've put up two toys already. I've put up a power switch, which is a toy from Disney Infinity 1.0. And I've put up a power switch because a power switch and a logic gate are, in essence, the same toy. There's two main differences between the two. The one difference is that the power switch can actually be modified by the player themselves by stepping on it, while you can't modify the position of the logic gate by stepping on it. And the second difference is really just in the naming of some of the states. As you see here, in a power switch, the two states are on and off, while in the logic gate, the two states are open and closed. And they've just changed the name. On is open and off is closed in a logic gate. So they have the exact same inputs, the exact same outputs, and the only two differences are the two things I've mentioned. Now, the first problem with the logic gate, and even with the power switch, is the name that they chose to use for them. The name of the toy itself and also the name of the states that this toy can go into are actually, I find, problematic because they don't explain what the toy is actually for. Logic gate is incredibly confusing. I don't understand why they called it that. Power switch is closer because the word switch is in there, and a logic gate and a power switch are indeed switches. They can switch between two states. Now, the best way to wrap your head around it is a power switch looks a little bit like a light switch. And it kind of functions a little bit like a light switch, but we'll explain the difference in a bit. In a light switch, there is the electricity from your house is attached to the light switch. And if you set the switch to off, then the power is cut off. It can't go through up to whatever light is in your house. While if you turn it to on, this just creates a path to allow the power to flow through to your light. And a power switch is sort of like that, except nothing like that. Because a power switch is more like, imagine you had a light switch in your house, and if you set it to the on position or the top position, then a light on one side of your room came on, and if you flicked it to down, that light turns off, but a light on the other side of the room turns on. That is more what a power switch and a logic gate does. It takes the same input, which in the case of a light switch is power, and it can send it to one of two possible places. That would be the output or the input block, which is so horribly named because it sounds like this is something that's blocking your input, which it most certainly is not. So when a logic gate is set to open and you send a signal to the input, the signal comes out output. If it's set to close, the switch is now in a different position so that if you send an input, it will come out this wonderfully named input block. And we'll get into that a bit more in a little bit. What we're actually going to do here is we're going to make it a very visual demonstration. And we're going to do that by using this power switch and a set of color changing blocks. So what we're going to do is we're going to say, if this logic gate opens, we want this block to turn green, which means if it opens, we want this block to, we'll say restore, which will turn it back to that gray color. Now if it closes, we want this block to turn green, showing that we are now closed, and we want the other block to turn back to this grayish color. And we're going to control the open and closed state of this logic gate here with the on or off position of this power switch, because I can step on this power switch as a player. So if I step on the power switch and it flips power switch to on, because I think I stepped on it once already. Not sure. Okay. We have stepped on the power switch, so the power switch is now in the on position, which is opens this logic gate, which is now showing us that this color block is green. If I step on the power switch again, it will turn off, which will close this logic gate and turn this block green. There we go. So we've just made a visual demonstration just so we can see what state this logic gate is in at any time. Flip it back and it's back to the open state. So we're going to put down a couple party cannons here. And I'll put one on this block. And I'll put one on this block. Now, as I said before, when you send an input into the logic gate, if it's open, which it currently is, the signal will come out output. So if it's open, we want the party cannon on top of this green block that's showing we're open to fire. While if it's closed, the signal will come out input blocked. So we're going to want this other party cannon to give us some confetti. Simple enough. Now, what you absolutely also need in this situation is you need an input. And so we're going to just throw down a trigger area. And we're going to say, if any player enters it, throw an input at this logic gate. So right now, that logic gate is open. We can tell because of the color changing block that we attached to it. So if I step in this trigger area, the party cannon on top of the green block should fire off. And there it goes, it fired off. Now we're going to set it to closed. So now the other block is showing that we are in the closed state. So if I step in this trigger area, the input should now go out input blocked and fire off the confetti from this party cannon. And there you go, that's what it does. Now, it looks pretty simple, and it is pretty simple, but it becomes a very powerful tool because you can use a single input to achieve multiple outcomes depending on what you put the state of this logic gate into. Now that goes more into, I would watch some of my videos on the basics of chaining logic gates. That's where you can change it from just two different options, and you can change it up to a lot more than two possible options occurring from one possible input. So what I'm going to do right now is I'm going to build just a quick little game just to show how we can make all this work together. I'm going to put a collectible tracker down, and I'm going to throw 5 collectibles around on the ground. Just whichever first one I see here. Sure, we'll throw some key cards down on the ground. There we go. We're going to have 5 of them. And we're going to set it up so if you collect them all, then that part or that logic gate is going to close. So when final collectible is collected, we're just going to close this logic gate. And we're going to change or add a couple things in here. I'm going to throw in a little text creator that says get all the stuff, or something simple. I don't want to waste a lot of time typing stuff out here. Now what I'm going to do is I'm going to say that an output is going to display line 1, which is telling us to collect all the stuff. So I'm also going to say an output is going to reset this collectible tracker so we make sure all our collectibles are up. And the input block is going to be once we've achieved, or once we've collected all these collectibles, the input blocked statement, if we step back into this trigger, is going to say thank you because we've collected them all. And I'm just going to run in here right now because, of course, we still have the fireworks set up to go there. Now, I could continue on at this point, but I'm kind of picky about certain things because right now, if I collect a couple of these items and then I run back into this trigger area, it's going to tell me again and again, collected all to proceed, and all these collectibles are going to pop back up. And I don't like it when things work like that. So I'm going to actually say another output from this gate is going to temporarily deactivate this trigger area, which will remain deactivated until you've finished. And when you finish collecting, it closes this logic gate. So I'm going to say when this logic gate closes, we're going to reactivate this trigger area. Now the thing to remember, there's an input to open and close a logic gate, and there's also an output from the open and close logic gate. And the output, which is right here, this open and close, they are momentary and they only happen when the logic gate is changed to that state. Now, a few keynotes on top of that is when you first open a toy box, all logic gates default to open and they will not send out that open message. So don't expect this block to turn green when you first load the toy box. It's not going to happen. It's only going to happen when a physical open or close message has been sent to this logic gate. Another thing to note is if the logic gate is open and I send another open message to it, it will send that open message out again. So if this logic gate was already open and I tell it to open again, if there's anything tied to the output of open, it will fire again, even though that logic gate is already open, which I actually use quite often to my advantage in various games. But now I've set it up so this trigger area is going to turn itself off after I display that message once. And if I walk back in here, nothing should happen because it is now deactivated. And it will not reactivate until I pick up these 5 collectibles, or I've picked up the final collectible. So 1, 2, 3, 4, and let's watch to see if that block changes color, and it did. So after we picked up the final collectible, the logic gate did close, which is displayed to us right here. So now if I walk into this trigger area, instead of it saying please collect all the collectibles and all the collectibles showing back up, the logic gate is closed now, so the message will come out input blocked, which we have tied to text 2 of this text creator and also to this party cannon on the green block. So that should fire off confetti and we should get the message of thank you. And there you go. Now, that is the simplest state of the logic gate. It's got the 3 inputs, which are input or telling it to open or close, and it's got 4 outputs. The output, it will send the instant it opens, or you force it to open, the instant you force it to close, and also the 2 possible outputs of this switch, which are, of course, output for if it's open and input blocked for if it's closed. And that is really all there is to a logic gate. But if you watch some of my other videos, you'll see that the very fact that we have such an adjustable switch in the game is how we can indeed create such powerful games in Disney Infinity. So, I hope this helps you a bit. If you have any other questions about the logic gate, always feel free to ask me here or at DisneyInfinityFans.com. And again, this is Samirian, and I hope this tutorial has been helpful.